So that's great. That's great, sir. So it's my pleasure, it's my privilege, and I'm really very fortunate to welcome our speaker for this second last day we have of this FDP, and Dr. Aditya Kamparia ji. He's working as an assistant professor in Central University of Lucknow, and presently he's posted at Amethi campus. I would like to bring in the kind notice of the participant, those who are on the YouTube live streaming, they are watching this talk. There are few researchers in computer science for whom the introduction is not supposed to be, not required, because they have achieved so much in their research, especially in research in a very less age, that we cannot think about the same, that how they have gone through this, how hard work they have done, and what wonders they have done in especially in research in the area of computer science. We have a few names, as already I mentioned you, that we have a we had the Deepak Gupta from MAIT Delhi, and then we have the Dr. Rishabh, and then we had Bharat Bhushan, Gaurav Diman, and then Aditya Kamparia ji is also of the same category, those who have achieved really very great heights in the area of research in computer science. And sir is having approximately 100 plus SCI index papers in SCI index journals of very, very reputation of having impact factor more than 5 and more than 10 as well. He's having 2 PhD awarded in his credit uh, till now, and presently he's guiding 4 scholars in the area of cloud computing, AI, machine learning, and various other fields. He is co-authored, and he's authored of many, many international books with a publisher from CRC, Elsevier, Springer. Approximately, I remember 20 plus books have been edited at international level, maybe more than that, numbers will be more. And more than 30 plus book chapters has been published by him. He's having approximately 6 to 7 patent filed as per my data 1 year ago. I am having maybe more he may have in his credit. He's having international patents also. He has already completed a major project in ICSSR in year 2019, I suppose. So, and in addition to it, he's a editor of very, very reputed SCI journals, and even in some transactions, he's an editor in there. He's on editorial board on there. So this is not brief. There is a lot of to to say about him, that what he has achieved. So that's really wonderful. And the area which he's going to speak today is really very, very important. That is explainable AI. As the Amar sir has also explained the things that what we people are doing nowadays, we are using a lot of plugins, lot of libraries on different tools which are available for machine learning or some other modeling. And whenever we do ask some questions to the researcher that how this decision tree work or random forest work, they do not know anything. They just may answer that we have imported the libraries. So this is not good. This is not good. And that's why this area is really very important to identify that how this model works, why this model works, because why is very important in research. And that's why we had requested Dr. Aditya Kamparia ji to please put some light on this area and share your valuable experiences which you have gathered in this to all of us. So over to Aditya ji, please, sir, go ahead. And thank you very much. Thank you very much once again, sir.
Good afternoon, everyone. First of all, thank you, Dr. Ashok Sharma, sir, for such a nice introduction. And I am highly thankful to Ministry of Education, Government of India, Ramanujam College, affiliated under University of Delhi, University of Jammu, and a wonderful team of this FDP on data analytics and artificial intelligence. The program they are organizing, the FDPs they have conducted, all are commendable, and it's applauding. So not wasting too much time, I directly switch on to my content. So I hope that is it visible?
Yes, sir, visible, sir, visible.
Okay, so this is the talk today, like machine learning models using explainable AI. So as we all know, nowadays, many people are working on this artificial intelligence field, and they have opted machine learning, deep learning, and they wish to involve some sort aspects of IoT also in their research work, or some MTech scholars also adopting this field. So by gaining the attention, as we all know, from 2010 onwards, this AI field basically gaining a lot of attention among the researchers. And as we are now in 2022, so what kind of intelligence we have achieved till now? So that is basically a kind of narrow intelligence, we can say. So I will talk about these all two aspects. So before going into the details, so these are the contents of my talk today. Like I will discuss our basics on what is AI. As most of us are, we are already familiar about these aspects, like what is AI, how it works, what are the fundamentals of AI, what are the core principles of AI. Then I will discuss on narrow AI, like how narrow AI differs from shallow AI. Like many of us or you worked on the deep learning models or machine learning models where you have applied shallow learning and deep learning and related concepts. Then I will cover, or we will discuss on the explainable AI part, which is the major or prime focus part of the today's talk. Then what is the impact of AI in healthcare? I mean, we can apply AI everywhere. I mean, there's not such a concern that we have to restrict towards only healthcare. We can go for finance, we can go for transportation, we can go for manufacturing, logistics, and then we can go for hospitality, travel and tourism. So you can apply everywhere. But why I have chosen particularly healthcare for today's talk, like healthcare is one of the more prime concern area. As we all know that COVID cases are increasing a day by day. So how you can adopt such kind of technique to your research, or you can enhance your research, you can leverage your research, and you can enhance your skills also. Then I will discuss some of the open problems, like what are the basic open problems which are there available in the market today in explainable AI. In AI, although a lot of problems are there, but what about this explainable AI? Then some of the suggestions from end, and then we take a question answering session. So coming to this AI, like we all know, like there is a famous scientist, John McCarthy, so who has contributed in the Dartmouth conference. He actually coined this term of AI. And according to him, he stated that a lot of definitions are available, but according to him, it is a science and engineering of making an intelligent machines. So we all know AI actually a lot of tasks nowadays. AI actually helped a lot to us. And UGC, if we talk about UGC or Ministry of Education or CBSC, they have introduced all these curriculum of AI even to our students also. So from a 5th standard or 4th class students now also know what is AI and what are the implications of AI, what kind of projects we can develop through this AI. So according to this AI, we have to provide a technology-based intelligence solutions, and which can basically facilitate a human task easier. So it actually acts as a bridge between a human and the machine. Then how it can perform a bridge between a human and machine. So we heard about a term that is human computer interaction. So which also goes up popular nowadays. So most of the IITs and even some Central University, they have started work on this human computer interaction, and separate funding has been provided from the Department of Science and Technology for this SCI. Then how you can involve simplification algorithms, how you can involve heuristic algorithms, mathematical algorithms, logical algorithms to facilitate your task easier, and how you can simulate the human activities. So all these things comes under AI, so which most of us are already aware about these things. But the minor part, or we can say some of the conclusions on this AI is whether is it an utopia, or we can say is it a myth, something like this, or can we take AI as a risk or threat? Like the famous company from Boston Dynamics, if you have seen certain videos from there, so they have developed fantastic robots nowadays. And even if you go for cleaning, I mean, you are cleaning of washrooms and all these stuffs have been done by the robots. So will it lead to a cause of extinction to human beings? Or can you think a science without a human involvement? So all these questions comes into our mind. Or Is it a stoppable technology? Can we stop AI? Because if we see the current markets, earlier in 2004 or 5, if I talk about this AI, so this is not a buzzword. But nowadays, AI, machine learning, deep learning, IoTs, these all are buzzwords where people want to do a lot of stuff in these fields, and they are gaining attention. Their research is gaining attention across the worldwide. Then in this picture, if you see, there is a concepts, or the focus is basically to illustrate the concepts of AI now as well as in the future. So 3 kinds of intelligence has been defined. So one is artificial narrow intelligence, then general intelligence, and super intelligence. So what we are currently doing, or the timing which we have, that is artificial narrow intelligence, where the focused, where the job has to be executed, and a focused task has to be executed without self-expand functionality. Now, what is the implication of this artificial narrow intelligence? The implication will be job could be enhanced. Okay, it can outperforms humans in multiple actions, like we can take the example of medical diagnosis, logistics, driving, financial advices. So all these things, our machine, machine is giving to us, and certain predictions machine has to be made, and based on that, human is going to take the decision. Now, coming to 2040, if I talk about the 2040 aspects where the artificial general intelligence will come. So we have to move forward from the narrow to general intelligence. Now here the broad task has to be performed, and the capabilities comparable to humans, it get improved. Now the problem for us as a human is job could be at danger. The job become at risk. So we have to compete with humans across all the endeavors, like what happened in AGI, like online degrees. Let's say robot can earn the online degrees. So how you can validate those aspects? So that would be a problem, and we have to convince that human that it is actually a human being or not. So you remember the Turing test. So same kind of concepts comes in the artificial general intelligence. Later, as soon as this period goes, after that, there's a term called artificial super intelligence comes into a picture, where the intelligence has to be demonstrated beyond the human capabilities. So it actually outperforms the humans and helping to achieve the societal objectives or threatening the human race. But we can't say complete human intervention is not there. There has to be human intervention, but the super intelligence goes beyond that, where the humanity is at risk. Then through this picture, so this image I have taken from the ESOMA. So ESOMA is one of the largest manufacturer of robots. So they are going to develop the robots. If you heard about ASIMO, so that robot basically from this ESOMA company only. So this is a roadmap to artificial general intelligence, where we have shifted from weak AI to strong AI. Earlier, the weak AI concepts was there, where we are going to take the rule-based systems and expert systems we try to make. Then we have to use symbolic logics, functionalities, mathematical implications. So now the time has been changed, and we have to move from these aspects to strong AI aspects. Now, in case of weak AI, there are 3 categories. So in weak AI, whether we are going with non-simulation tasks or we are going with simulation tasks, and with the human intervention or without the involvement of human being. So in case of weak AI, here the machine states has nothing to do with the human or other cognition activities. So a computer can perform the task that is required intelligence, but no intelligence is required, where the machine has states which has nothing to do with the human cognition. That happened in case of weak AI with non-simulating kind of stuff. Now, in case of simulation, where the non-human involvement is there, but a computer can simulate the cognitive process in the non-human brain. Here, the computer can actually simulate the process, which we are doing nowadays, which is happening now up to 2025. This cycle goes. But at that time, there is an involvement of human, where a computer can simulate the human cognitive process, but there is no such correlation between the computer states and the cognitive states of the brain. See, we have to understand this very clearly, that the cognitive states of the brain matters a lot in artificial intelligence. Like you have to establish a correlation, you have to establish an association between the computer states as well as the cognitive states of the brain. Once that limit or level reached where the computer states on the cognitive states of the brain get meshed, then it automatically becomes the strong AI. So currently we are not into that phase, but we are leading towards that phase, because by the time due to involvement of we can say latest technologies, like we say in case of robotic sectors, so submarines, so they are trying to automate them, and there is something we all aware about it, that is auto ML or auto deep learning. So all these concepts comes into the market where you just need to do a drag and drop kind of future, like if you are aware about the Tableau, so there we have to make the data visualizations from the pick and plug kind of stuff there. So same kind of stuff is available in the market, like lot of leaders are there, that is Studio.ai. So they are basically working on and responsive.ai. So they are obviously working on these automated ML kind of stuff, where you need not to code anything, you just need not to import the libraries, you just need to there's a kind of dashboard there where you just pick and plug all those things, drag and drop, and then the task would be done. Automated ML. So in this weak AI and simulation, you have to involve the human related activity where you can establish there is not such relation between computer states and cognitive states of the brain. Then later I shift towards this in the era of 2025 to 2040, where there is a strong AI comes into the picture, but the cognitive states which actually observe in the machine, they are not identical to those in the brain. Please remember these points. The cognitive state which found in the machine, they are not functionally identical in the brain. So it is not able to create the human thought process. The human which thinks, the human thought process. So it is very difficult to recreate the human thought process. Whatever the human, so a lot of researches nowadays going on neuromuscular or neuroimaging kind of stuff, where people are going to take the brain computer tomography images and they try to identify whether the hemorrhage is there or stroke identification, all these kind of things. But the important aspect here is the signals, okay, with the brain signals which we are taking. So the scientists, they are working on that only. So we all know Elon Musk, he is the founder of Tesla. So who is working on this neuroimaging chips. Okay, so that is basically leading towards the strong AI. Now in 2040, where the superintelligence comes into the picture, the cognitive states of machine are identical to those in the human brain. So that is the leap which we can say, not physical by nature, but logically, whatever the human thoughts or whatever the human thing can feel, can express the things, it can act, same sort of stuff would be performed by the machine. Why? Because they have matched the cognitive ability of system as well as the human being. So that exactly happens in robots. So if you see the Boston robots, so some of the functionalities they are doing similar to the we can say super intelligence kind of stuff. Then what we have to understand, like in general intelligence, we have to understand the abstracts and the concepts. Then we have to explain why it comes. Obviously, we have to be creative like a children. Then the model should justify whether this is right or not. And then whatever the model you have created or the robot or the kind of agent which you deploy, it has certain emotions. Okay, certain feelings. That's what the scientists trying to do nowadays, to put certain kind of emotions, certain kind of feelings into the we can say object. Now the concept here is the second point which I explained, like the model, whatever the decision model is taking, because nowadays we all are moving towards the accuracy. So if we just do certain experiment, we take a data set and we perform certain methods, we take certain classification methods, we opted certain regression methods, okay, and then we able to take the trained data set and then give some test vector test on it, and then we get certain accuracy. Then you try to predict precision, recall, sensitivity, F-score, all these things you did. And then you say that my model is what, and this is what the accuracy. But how it comes? The question here is how it comes. So most of the state officers, or we can say consultants, or we can say legal, ethical, those persons who have these sort of stuffs working for companies, how they can verify your claims, the claims which you put up, whether is it correct or not. So for this purpose, explainable AI will come. But before this, there is one more concept which I would like to focus on, that is ambient intelligence. So ambient is also a part of narrow AI related concept, where we know it is basically a future vision of computing where implicit and explicit devices are not required. There is no need of implicit and explicit device. Just there is a board where the sensors and processors get embedded into the device, and the user can ask, or the work facilitated by the user can be performed, or whatever the needs and desires of the user there, that could be performed. So here, if you see, it's a kind of home automation system or any kind of automation system or society. So where people are looking to that in future, you see about 2030, 2040, these things will be in there. Nowadays also people are installing these at their homes, but in coming future, that will be in the boom, where everything would be automated. So that is kind of ambient intelligence, where the intelligence perceives the external environment and according to that they behaves. Now, talking about this explainable AI, which is the major topic of the today's talk. So traditional AI solutions are used in day-to-day life aspects. So we have seen many aspects of the AI. So, but which is the important area that I would like to focus on, that is a medical. So medical is a critical field where exactly it affects the life of a human. So we all know that medical has important part, like what Corona is doing nowadays. So many of us obviously infected with the disease, and we get cured. Then in this, if it is a deep learning task, if I talk about the deep learning, so today's ML techniques, deep learning, neural networks, they all are generally a black box. They all are kind of black box stuff where we don't know what is going inside, because you have thrown certain set of images, certain set of data to a machine, and then machine is going to predict the output. But how exactly that output comes, whether the output which is given by a machine, can you trust that output? So that is the important question. That is the major question among a researcher or among any student who is doing their PhD or masters or bachelors. Whether are you going to, we can say, trust your model? Do you have certain kind of an anxiety that how your model exactly reaches to that decision? What kind of implications, what kind of logic, what kind of clarifications, what kind of explanations our model actually applied, or what kind of technique our model actually applied to reach to that conclusion? So that is unclear. Okay, so the thing here is that we have to go for interpretability. So there is a need for interpretability. That is the important aspects, or we can say a sort of transparency in the model. There should be a transparency in the system. Like nowadays, many people have opted, during this COVID period, many people have opted the medical insurance plans. So many of us get affected by the COVID. And when you go for claim or reimbursement of your amount, company denied. Company said that we will offer only 70% or 60% to you. So they are not going to give the entire amount as per what they have claimed. So how you can trust whether that company is good for my future or not, whether I have to spend my next premium policies or my installment to that company or not. So this is what the requirement. Because at the time of when you take a policy, at the time of company said everything that we will give you full 100% waiver. But at the time of reimbursement of things, they will not. They will put so many charges there and they will come reduce it to 70 to 60%. So the important task here is explanations. So then we have to go towards explanation. We have to ask them that where you deduct our money. Let me show the plan. If let's say you are giving 70%, then where my 30% get deducted. So our model should be like that. In future, our model should be like that, that it is going to explain each and every aspect. Suppose if in a data set, let's say I have 20 features. So out of those 20 features, each and every feature has a capability that what is my importance. Each and every feature has to show that this is my importance and I have to be at this position. So Features importance also played a major role in explainable AI. So that is what the interpretability means. But how we can achieve this interpretability? So we are going to achieve this interpretability by extending our conventional AI models. So conventional AI models means we have to move up from the fuzzy based systems, rule based systems, expert based systems, oriented AI models. Okay, so we have to extend them. Basically, we are going to extend these models, and once we extend these models, we are going to achieve this interpretability. Interpretability means transparency. So transparency means we can go for understandability, like the model understandability has to be improved, model comprehensibility has to be increased, model fairness has to be increased, model trust has to be increased. Okay, then privacy also has to be enhanced. So all these aspects are there which we have to take into the account. And then if we combine all these efforts, by combination of all these efforts, there is an area which comes that is called explainable AI. Like we have to explain our model ki if this result comes, so that is the reason why I am choosing this is my feature which is having the highest rank, or which is having the more important. And if I have given 100% waiver to some employee, why I have given 100% waiver? And if I am giving this much incentive nowadays, because that happens in every sector, even if I talk about academics or industry, we are giving incentive to our employees, but that incentive is not even. Okay, that is uneven, and we usually compare that is based on your performance, annual performance incentive and increment. So when we compare with the other guy, we say that there is a very limit, we can say not a marginal kind of difference in our incentive. But the company should explain that the exact reason that why you are going for this, because you have because these are the limitations in your work, or these are certain kind of pitfalls you have. So that is the reason where you achieve. So interpretability basically helps. If I talk about the database aspects, or we can say ML aspects, it helps to ensure impartiality in decision making, that is to detect and correct from bias in the training data set. The goal should be to detect and correct the bias in the training data sets. It facilitates the provision of robustness by highlighting the potential adversarial perturbations that could change the prediction. So we know that for ML or deep learning, people are going to work on these perturbed images, and they are going to apply the causal reasoning, and then they apply certain attention, they generate attention maps, they generated grad cams. So all these things we are utilizing in our work through the GAN or certain other aspects. Then the interpretability should guarantee that whether an underlying truthfulness, causality means that is a cause and effect kind of relationships. I mean, if you pick any data feature, or if you put any feature of the model, or if you take any feature from the model, what is the cause and effect of that feature into the another feature? So that is basically the causality in case of machine learning. So those who are PhDs and they are doing PhDs, or those who want to do PhDs, so that is a causal reasoning. That is one of the great field, and lot of potential and upcoming challenges are there in this field already. So you can take this topic for your research work also. That is one of my suggestion. Go for causal reasoning. Then what kind of causality exists in the model reasoning? So these are the certain aspects which we have to cover in this interpretability. Now, if you see this, this is a database which I have taken from the Scopus source, where the interpretability of the result, or what is the growing literature of explainable AI in time. So if you see two aspects here, there's a mistake there, like the green, we can say bar, which is representing it is basically a responsible AI, right? So that I will also touch later, that what is the impact of responsible AI and how it differs from explainable AI. So these are all the future that is beyond AI things. So if you see in the graph, so these are the contributed works in the literature, where if you see in 2012, 13, 14, 15, 16, there is very marginal work on this explainable and responsive AI kind of stuff. But interpretability AI is there. Why? Because the people are using and they are working on expert system, they are working on rule-based systems, they are working on decomposable systems, they are working on fuzzy-based systems. So they all are interpreted kind of models. So if I talk about the like you are aware about KNN, decision trees, random forest. These all are the classification models. Then if you talk about the logistic regression, okay, they all are interpretable models of AI or machine learning. Then if you see from 2017-18 onwards, the rise of explainability and responsive AI comes into the picture. So the people are approaching toward that guy because they want to know exactly how machine actually predict this thing. Because if let's say I purchase a term plan, I should know what are the basic kind of riders are you giving in this my term plan, and what is the necessity of these riders, okay, whether and what is the maturity amount you are giving. So all these things people want nowadays through this explainable AI. Then this is the image source which I have taken from one of the very famous paper that is from Rossi, where they have explained the entire taxonomy of the explainable AI and the responsive AI in contrast to general as well as the super intelligence. And this image has been taken from the permission from the IBM. So what are the target audience in explainable AI? So that is important aspect which we have to understand. So it could be any domain experts, like it could be any medical doctors, it could be insurance agent, it could be any travel logistic company, it could be any property agent, real estate agents. Now but why? Now, what kind of, if such kind of insurance agents or medical doctors are there, so they have to trust the model. The important aspect is the trust of the model is important. Then through that only, because suppose if you train your model and you went to radiologist, so whether radiologist will validate your work on what basis? On accuracy basis only, whether he can diagnose the patient who is available at the real time? No. Okay, they will identify that what kind of methodology you implied in this. Okay, what kind of local interpretation of the work. So I will come into this later, whether the local interpretation would be there or not, the global interpretation would be there or not. Okay, what is the impact of that local feature on the entire global data sets? So all these things will see by the radiologist, and then only they can examine their patients. Then what kind of users affected by the model decisions? So why the interest is there? Because they want to understand the situation, that what kind of fairness, whether the decision you have taken, is it fair or unfair? So that is what the importance. Then data scientists are there, developers, owners are there, because they want to enhance their product efficiency, so that people can buy their purchase their products, and they can resell it, and they can then test it and give their feedbacks on it. Then the managers and executive board members. Now, what is the necessity for these managers and executive board members? Because they have to assess the regulatory compliance. Like in corporates, usually they have to understand the corporate legal advisories, and they have to understand the compliance among the two companies. So how they can, once there is trust, security, all these things would be there, then only they can trust your model. Then you have to certify the model compliance with, nowadays online degrees are available. So some of the university, they have started, or boards, they have started the online degrees. But what kind of validation is there? Whether that online degree is providing some kind of job to our students, or whether is it, the full leverage is there or not, the full academic, the credits would be covered or not. All these kind of things we have to take to reach the final decision. So these are the kind of target audience in our explainable AI, and the goal of explainable AI, which is shown also in this figure. So these are the important goals, like causality, transferability. If we are going to shift our model from one platform to another model, whether the decision has been changed or not. If you are going to shift your model from one mode to another mode, what could be the impact on the decision on this model, whether it changed or not. Suppose if you transfer your application from Windows to Linux, whether it get affected or not. So all these sort of things. Then confidence, fairness, the model is fair or not. So who is the audience? So obviously those persons who are working for government or regulatory agencies, they get affected by this. Then accessibility, the model is completely accessible or not. Interactive, the model is interactive, we can say there is an involvement of human and machine there or not. Then privacy awareness. This is very important aspect in explainable AI. Like we have to, the model should be have ability to explain the inner relations of a model by non-authorized parties. But sometimes what happens, that these non-authorized third party, they can also compromise the differential privacy of the data. Whatever kind of from where the data has been originated, so that could be actually breached by this non-authorized third party. So that is also a major concern. So that is also we have to cover through this explainable AI, so that our data gets secured and they're not able to access the data. So these are the kind of important goals which are there in the explainable AI. That is the focus. Now, I would like to focus on these two terms, because many people get confused sometimes by understanding these two terms, like what is the major difference between interpretability versus explainability, because they get confused by incorporating interpretability with explainability. So my friends, these two terms both are different, they are not same. So if I talk about in terms of model perspective, in terms of machine learning model perspective, so explainability we can see as an active characteristics of a model. So here explainability means we have to deal with we have to clarify the internal functionality of the model. Like we have to explain the detailing of that model. Let's say if we have particular sample in the data set, so what kind of functionality for that entire sample. So let's say in a particular sample, 20 features or 15 features are there. So what are the role of these features? What is the impact of that particular row or sample on the another row? So that is basically called as a active characteristics of the model. So that you can govern by using explainability. But interpretability talks about the transparency. So that is a passive model where we have to refer to that level where a model can make sensitive for the human observer. So in transparency, can we say if a model understands better, means the model can understand the things by itself, then we say that model is much more interpretable. We can say that model is much more transparent, because once a model can understand things by itself, so in current scenario that is very difficult, but by the incorporation of that explainable AI, these things become easier nowadays. So a model can feature different degrees of transparency, or we can say different degrees of understandability. So if you see a model is transparent, automatically it implies that it is understandable. Now to implicate this understandability concepts, these transparency of the models get divided into 3 categories. So that is very important, because all the algorithms which we are using nowadays, so we have to justify whether that comes in the transparent category or they have to utilize post hoc capabilities. Now, what is this post hoc capability? That I will cover in next coming slides. So these transparency of the model get divided into categories like simulative category, that whether that is model is simulatable, whether the model is decomposable, or whether it is algorithmic transparent model. So these 3 terms are very important. So I will explain these terms later. Like in simulatable model, as a brief, whether the model is simulation or not, whether the simulation could be performed in this model or not. So that is the meaning of simulatable model. So it is basically comes from simulate, right? Then decomposable, like is it further breakable into certain parts, like whether can we use certain kind of constructs like if else, we can go with that. Or algorithmic transparency model means whether we have formulated certain rules, and based on those rules, the algorithm itself is transparent, is clear that how the decision comes into, or how the output predictions has been made by the model. So that we talk about the algorithmic transparency. So understandability basically measures how the decision actually taken by the model, but it circulates around these 3 aspects like simulatability, decomposability, and algorithmic transparency. Yeah. Now, the focus is to build human transparency, human interpretable models, so which basically comes from this scope of interpretation. Now, if I talk about the model is transparent or not, so you have to talk about these 2 interpretations. So this image I have taken from S2O.ai. So who is the leader of this AutoML? So in this scope of interpretation, you have to talk about 2 interpretation, whether we are going for global or we are going for local. So we have to understand the difference between this global and local interpretation. In case of global interpretation, just a minute. In case of global interpretation, you have to explain the correlation between the dependent variable as well as the independent variable. I'm sure we all are aware about dependent variables, so which are response variable, and independent, we can say they are predictor or explanatory variable in our data sets. So based on this, we have to identify the interaction between this independent as well as dependent variable on the entire data set. If you are identifying a correlation among them, among the entire data set, then you are going for global interpretation. So what is the implication, or what is the helpfulness of the help which we achieve from this global interpretation? We are going to explain the context of the decision classification, that whether the model has been performed classification, regression. So on the entire data, it is going to covered. But in case of local interpretation, we are going to explain the interaction between dependent variable as well as independent variable for a single row, or we can say certain set of subsets of the row, certain subset of the sample, certain subsamples of the data sets. So what it means, it helps in identify the local trends and intuitions. Like we all know that elections are going on in 5 major states, election will be there. So every party, they try to, worked on the local villages also. Okay, so villages, then we can say small janpads, and then they go for city, because then ultimately they are going to win for the particular states. So the local interpretation is very important. What is the the trend, or we can say the trend which we are seeing, if any party we can talk about. So what the trend they are seeing in the villages, what trend they are going to see in the janpads, then in the city, then urban areas, remote areas. Based on that, the history of that political party or any party get be decided. So that scope, global and local, played an important role in case of transparency of a model, in case of ease of understanding of a model, and the ability of a model to answer the query which is issued by the, or fired by the user. Then in this picture, you see this is what what we are doing. Like we give some set of training sample or training data to a machine. Machine perform some learned functions. They are going to apply certain approximated functions. Okay, they are going to apply certain algorithms there. Okay, some kind of activations we applied, and then machine give you certain decision or recommendation. But the user get confused. Sometimes we have to ask from a model that why you did that. Okay, why not this? Why only this fail or pass? Okay, and if you get fail, when do you get fail? Suppose if a student get fail, when do you get fail? So machine has to give that you have to fail in this semester, certain like this. Like if I fail in second semester, then how can I trust you? Okay, whether my marks are wrong in that particular semester, then only I can trust the machine or not. If the marks get wrong, then how can I correct my error? So these all questions comes in our mind at the time of explainable AI, by the time of normal conventional AI. But with the involvement of this explainable model or explainable interface into a machine, now the user actually get understand the task of the user would be easier. So there the user can understand like, okay, yes, why I get failed. So I know when you fail, then how should I trust you? Okay, I know when you succeed. So all these questions which we asked earlier, okay, so then the user actually know, okay, these are the answers of my question, which I should know exactly at the time of training a model, at the time of getting any kind of prediction. So this is actually a SCI part, which is nothing but a human computer interaction, where a AI model, it acts as a bridge between AI and SCI. So what is a bridge? The details of the model, the reasoning behind the model, the transparency of the model, the scope of interpretation of the model, and then finally the user gets satisfied that this is what my machine is providing me the output. Then in this figure, you see, this is the image which I have taken from DPHI. It is also one of the very renowned AI web. They are working from a lot of years ago in this AI field. So where you see the now why I'm giving too much stress on this interpretability, because you see the relation between accuracy as well as interpretability, because many researchers and many scholars and many AI builders, they are working on the accuracy part. So they just say that this is the accuracy I achieved in database. 97% is given, I have achieved 98%, my work is better than PhD awarded. Okay, but how that accuracy actually achieved? If you see these models like rule-based system, linear regression, decision trees, KNN, additive models, Bayesian models, all these models are transparent models. Okay, all these models are transparent models. So for these models, there is a certain thing called post hoc explainability. Okay, so that is not required. Post hoc explainability means whether you are going to explain these terms with the help of textual explanation, whether you are going to use certain visual explanation, whether you are going to use certain tabular explanation for them. Okay, so all these things comes under post hoc explainability. Then if you see these techniques like SVM, ensemble, deep learning, okay, and your recurrent neural network, your multiple recurrent neural network, so all these kind of stuff, they require the post hoc analysis because the transparency in this model is not preserved. Okay, so if you see the model accuracy gets higher, so obviously ensembling, so you perform 3-4 technique, you taken 3 to 4 classification techniques, perform the ensemble of the apply bagging and boosting, perform majority weighting, and then you say this is the result which I am getting higher. Then you go for deep learning, then you go for explainable AI. So explainable AI, but if you see the impact of this, the interpretability of the model is more in this rule-based learning, linear regression kind of aspects. Okay, but as soon as you comes into this accuracy part, okay, so it gets lower. So this is what the explainable AI, where we have to involve the hybrid modeling approaches. So everywhere in the model, so nowadays people are also merging their models. So they try to apply certain optimization in the model. They try to take 2 algorithms, merge it, take the difference, then give in a sequential fashion to another algorithm, and they give the outputs. They're going to apply the transfer learning models. So earlier what happens? People apply people try to apply transfer learning model, but they opted single transfer learning model. But nowadays people are performing sequential transfer learning. So they take output from one transfer learning models. It could be any model. It could be Inception, VGG, LXNet. Okay, and then they again feed the output by taking certain attention maps to the another we can say transfer learning model. Why? Because they are going for hybrid modeling approaches, because they want to preserve the modeling approaches. They want to go for feature engineering. They want to interpret the feature engineering. They want to interpret the feature selection process. So that is what the future of the research, that is explainable AI, which is future research area in AI model, responsive AI. Okay, so this is what the explanation in this scenario. Now, if you remember, so this is the post explainability. So 3 techniques are there, transparent techniques, which is basically a conceptual look behind the explainable AI. So we can say these are the backbone of this AI. So our process should be simulatable. So like say your x1, x2, x3, these are certain inputs. So it could be weight, height, and age. And our model is getting trained based on certain parameters phi. So that could be any parameter set, any feature set. And then it is going to give certain prediction. Now in this simulatable concept, you see, we are going to design certain mathematical function. And then we say that output is 1 or output is 0. So if you remember activation functions, so in activation functions, whenever you're going to plot sigmoidal or logistic or tanh or any kind of functions, so there you have to provide certain functions, and based on that function, you are going to describe certain statements for that. Okay, we can say certain calculative or certain mathematical part of that, like pi equals to x, that could be linear, y equal to 1 divided by 1 plus e raised to power minus x, that is basically sigmoidal function. Okay, then it could be binary and bipolar. In case of bipolar, it could be 1 minus e raised to minus x divided by 1 plus e raised to, certain like this. So these are certain activation functions are there. So if we apply certain these kind of functions, so your model is simulatable or not, whether you can easily identify the trends between the x and y axis or not. So then you can say the model is simulatable. Decomposability aspects means if I take the whether the height of a person is greater than 180, then I say that is a male. Otherwise, if the weight as well as age of the person is greater than 150 centimeter, then we say that is a male. Otherwise, it is a female. So whenever you make certain kind of if else if construct, certain kind of decomposability aspects, so then you say the model is decomposable. Third aspect is algorithmic transparency, where we made certain rules. Like based on that certain rules, if you see, you obviously see this picture where you see the 95% of the positive training samples have the height greater than 180, that is rule 1. Another rule I impose, 90% of the positive training samples have weight plus age greater than 150, then I say it is a rule 2. Similarly, based on that, I try to propose another rules. So like that, like itself at each and every sequential step, our algorithm is clear. It is very much clear to a user. It is very much clear to a machine. And then according to that, machine explain everything. So this is what the conceptual look behind the explainable AI. Now, this is what the post-hoc scenario, where in the post-hoc explainability techniques, our model is black box. We all know. So we have given certain input instances to our model, and based on that, model is going to predict something. But what kind of post-hoc explainability there? So it could be the model simplification. It could be the textual explanation of the model. It could be feature relevance. It could be local explanations. It could be visualizations. Now, what could be visualizations? Means the based on the inputs you are giving, what is the behavior of your output. So you can visualize these with the help of SOM plot, box plot, picture plot, dot plot, any kind of plot you can opt. Okay, through that box plot, histograms, through that you can going to visualize the things, that what is the kind of behavior. So that is the post-hoc explainability. Okay, then local explanations. Local explanation means if you try to change a certain we can say features of any input, then what is the we can say implications or result in the prediction. What happens with the prediction Y if we slightly change the feature of this input XI? So that is local explanation. Then feature relevance. So we all know a lot of feature relevance techniques are there, feature importance techniques are there, which you can apply. Okay, like random forest also can use as a feature importance. Okay, extra tree is there also, SAG is there also. Through that you can able to identify among these available features which is my important feature. So that is the post hoc techniques. Then explanatory examples. Explanation by examples means certain input you give to a machine, machine will give X output B, A. Let's say B input you give to machine, machine will give output correspond to that B. So example by example, your model able to refine, let's say these many samples I am getting, you can say they have a headache, they have fever, okay, they have sore throat, okay. So let's say they are going towards positive COVIDs. Okay, otherwise others are winter diarrhea, because nowadays, you know, in winter diarrhea is you know, it's a kind of fever which comes, and then people get suffered from vomiting and other stuffs. So that is a winter diarrhea. So giving example, explanation by examples, you are going to lead the decision. Then text explanations. Okay, you are getting certain output for any kind of input with the threshold, within the threshold. Okay, so that is text explanation. Then model simplification. Your complex model is there, like decision tree. Okay, we are going to navigate it to sub branch. We are going to divide it into certain levels. Level by level we have divided, and then we able to get the simplified model at the end. So these are the certain techniques which are called post hoc explainability techniques. Exactly, actually, I want to pinpoint one thing here. These post hoc techniques divided into two categories. One is model agnostic, and one is basically model specific. If I talk about model agnostic, so these visualizations, explanations, feature relevance, text, these are called model agnostic techniques. But if I talk about the model specific technique, so your we can say deep learning, recurrent networks, your SVMs, okay, and then your convolutional neural networks, okay, they all comes under the model specific techniques, right? Because they're not able to explain itself the transparency. Whereas if I talk about the KNN, okay, random forest, right, logistic regression, they all are transferable techniques. So this is what I talked about earlier, where the people are going for hybrid model. They give certain input to a machine, it performs certain output. Now that transparent design methods we have to involve in the machine explainability. That you can go for KNN, you can go for decision tree, okay, you can go for rule-based learning. Now in this picture, what we identify, if you go for convolutional neural networks, okay, or any kind of image-driven neural networks, apply any kind of pre-transferred models. So these are the certain what user trying to do with the images. User trying to generate. So the first image which you see, this is generated from the heat maps. Okay, that is basically a heat map. The user trying to coin their image with the certain represented, certain rendering. So that is basically rendering. So they have performed the rendering of images. Then the second picture which you see, these are the attention maps. So one particular picture, they are going depth into that pixel by pixel positions, and they are trying to generate the attention maps for them. Third is basically the grad cam. So this is a picture generated from the grad cam. That is the activated class mappings. Okay, from where you are going to compose your pictures into pixel by pixel positions. right? So then if you see this picture, in this picture, what we are trying to identify, like this is a simple neuron. This simple neuron, like how exactly this picture comes. So this is simple neuron. Then from this neuron, we have proposed this channel. Okay, we call these channels, like this is a channel 1, channel 2, channel 3, like that. There are thousands or hundreds of channels are there. Now within these channels, there are multiple layers which are present. Now in this layer, we able to identify minutely that this is the picture of what. Like from this picture, it is very difficult to identify if this is a dog or cat or this is something else. Okay, but from this picture, it directly identify. Okay, now if we zoom this picture, why? Because we have gone for the layering of this picture. So you can able to identify this is the kind of dog and which category of dog. Is it a Pomelian? Is it a Labrador? Okay, the German Shepherd, whatever it is, right? So these all things you are going to cover. Means layer by layer you are explaining your models. So you are moving forward from neuron, then you are moving towards the layers, then you are moving towards from layers to we can say images, okay, channels. Then this is a picture, famous picture. So you have seen many times this picture somewhere. So in this picture, they try to perform a test which is called a LIME test. Okay, so LIME is a kind of library. Basically, I will explain this later in my second lecture, where how we can utilize this LIME to identify whether this picture shows which category of guitar. Is it an electric guitar or is it an acoustic guitar? If it is showing an electric guitar, then why it is electric guitar? If it is showing an acoustic guitar, then why it is kind of acoustic guitar? So if you see clearly here, so actually in LIME, what happened, there are certain kind of associations. So positive associations and negative associations will be there based on the probability scenario. If you see the probability, they're the probability of 0.32 they are getting. Okay, the 32.32 probability is that this chance is that this is electric guitar. So electric means based on the wiring of this. Okay, based on the wiring configurations, you see the machine exactly predict that this is the electric guitar. And based on the hardware part, based on the wooden part of this machine, where it is 0.24% we are getting, so that machine can predict that it is acoustic guitar. So now here in this reasonability is involved. Okay, we can't directly say this is the electric guitar, this is a guitar based on certain features. So particular explanations, particular reasonability should be involved there. So that is the major driving force behind the explainable AI. Now, if you talk about this transparency of different techniques here, so this is a graphical illustration. This I have taken from one very famous paper, okay, where they have explained the level of transparency of the different ML models. Like I talked earlier that linear regression, KNN, decision tree, rule-based, Bayesian models, they all are transparent models. Okay, where you exactly see because they all satisfy the property of simulatable, decomposable, and algorithmic transparency. Like if I talk about in case of decision tree, okay, there they provide the direct support, and at each and every levels, you are going to compute the impurity. Once you are going to compute the impurity, then if the impurity is okay, you proceed towards the next level, then towards the next level, certain like that. And then you are able to identify the classes. In that particular level goes for which class. So obviously it is simulatable and it is decomposable. If I talk about KNN, KNN is basically a lazy trainer. We all know, okay, where we are going to identify the K-similar training instances, and then prediction is performed by majority voting. Okay, so it is decomposable also and it is simulatable also. If I talk about the fuzzy-based systems or rule-based learners, where they are easy to interpret. Why? Because linguistic rules are there. We have formulated certain rules, and then based on that, we try to predict the decisions, right? So rulist coverage and specificity are constant. So fuzziness, what is the advantage of fuzziness is fuzziness improves interpretability. Okay, then talk about the additive models, okay, where the certain set of features we have to adopt, and based on that, we are going to train our models. Then Bayesian models are there, where the joint probability concepts comes into a picture, okay, where the occurrence of any particular event depends on the occurrence of the past events. Okay, how that past events exactly affect the event which is going to occur. Okay, what is the implication of that? So they all are simulatable, decomposable, as well as the algorithmic transparency. Now in this picture, this is a picture which I have taken from this famous paper published in Information Fusion by Emerita and all. So they try to classify explainable AI in two aspects, that transparent model as well as post-hoc explainability. So which I already explained you, that post-hoc explainability again divided into agnostic as well as specific. So agnostic means which you can explain by simplification, where you can give feature relevance, you can give local explanation, you can go for visual explanation, okay, you can go for feature relevancy. So all these kind of stuff where agnostic you can go for, and what kind of algorithms which are there. Okay, so these facts are till now hidden from us. So as soon as the concept of explainability comes into the picture, we exactly know, okay, game-based theory is there. So the relevance should be goes for feature relevant explanation. Then we see the decision tree is there, where the simplification explainability we can achieve by using the simplification aspects. Rule based, there we can go for. So you see certain references are also there, which I have coined there. So these are the scientists who have already incorporated these things in their work, and they have explained these facts. Then visual explanations. So if you want to go for sensitivity, saliency, specificity, then you go for visual explanation of the, then Shapley plots, or you go for dependency plots, conditional plots. Okay, these all plots you can go for visual explanations. So these all the kind of things which we have to cover for normal techniques. Like that's a model agnostic techniques. Then model specific techniques where we support vector machines are there, then CNNs there, recurrent networks there, then multiple we can say classification systems are there, ensembling there. So they all covered actually post-hoc explainability, where you go for explanation by simplification, architecture based. Like in CNN, we opted different transfer learning models, and based on that, we try to identify the output of any model. Then on these features, now these techniques which are there. So these are the certain techniques. So the methodology part has been covered. The formulation has been covered. Conceptual look has been covered, at how exactly explainable AI comes into a picture, and what are the kind of thoughts or methodology behind the explainable AI, the driving force. Then these are the techniques and library. But the thing is how we can implement it. The implementation aspect has to be covered by using these 4 to 5 techniques which are there. Like LIME is there, then SHAPE is there. So LIME basically is local interpretable model agnostic explanations. Then SHAPE is there, Shapley additive explanations. Then LE5, which is like explain like IM5, that is the full form. Scatter is there. Apart from that, you have extreme gradient boosting is there, and extreme boosting machines are there. Then dashboard is there. Okay, so a lot of we can say explainable AI libraries are there, okay, which you can use in your work, and then you can go for explainability of model. So in the next section, I will explain you by doing the things like how we can incorporate 2 to 3 libraries in our work, which is going to explain the model explainability. So these library basically uses feature importance, partial dependence plots, and individual expectation plots to explain the complex models which are less in nature, like logistic decision, KNN. Okay, so now what is the meaning of this part? See, nowadays people are using lot of plots in work, okay, but they don't know what is the necessity of these plots, whether I should go for this plot, box plot, whether I have to represent my work with SOM plot, whether I have to represent my work with dot plot, which kind of plot I have to use, okay, whether histogram is required or not, right? So these things we have to understand. Okay, so partial dependence plot actually visualize the effect, okay, of a change for a feature. So you pick certain feature from the data set and keep everything as a constant. So if you keep everything as a constant, then you're able to identify the impact of that particular feature on the entire data set, okay, by using the visualizing this partial dependence plot. So you see this partial dependence plot. So these are the 2 plots which we have generated. So that is a sample on the education num. Okay, that is one of the feature from a database, from a data set, where you are going to observe this partial dependence plot with SHAPE, and this is a partial dependence plot with scatter. Like what is the impact of this education num feature on the entire data? Okay, on the entire data, what is the impact of this education num? So that is going to be covered by using this partial dependence plot. Okay, Ashok ji. Okay. Then second is individual conditional expectation plot. So in this individual conditional expectation plot, we are going to show the effect of change for certain feature. Okay, just like partial dependency. But the thing here is the point of view is local. So in this individual conditional expectation plot, what we did basically, we are going to see the change for a certain feature for all instances in our data. So let's take this example. In this example, this is an image which we have taken where the cancer prediction rate, we have to identify the cancer prediction probabilities is mentioned, okay, for a woman, okay, based on their ages. Okay, so in this picture, you clearly see for most of the women, okay, for most of the women, there is an increase in predicted cancer probability with increasing age. So as soon as their age is increasing, the cancer probability rate is also increasing. Okay, so but for some of the women, okay, you see this bar as a 0.4. For some of the women, the cancer probability rate above 0.4, okay, the prediction does not change at higher age. So if I compare with the higher age aspects, so this prediction rate has not that much change compared to the aspect which is at the lower prediction cancer probability rate. Okay, so if you see less than 0.4, the cancer prediction rate is lesser than the 0.4. So what it means? So that means basically we have to go for individual conditional expectation where the point of view is local. Okay, so we are going to see the effect of change for a particular feature, that is age, for all instances in our data. Okay, at certain probability, we have to identify the what kind of change it actually performed, right? So this is the meaning of this individual conditional expectation plot. Now we are going to see this library, that is SHAPE. Okay, in this SHAPE, what happened? Basically, SHAPE works on the game-based theory approach. Okay, to output of any ML models, whatever the models you apply, so explanation of that ML model, it could be governed by this SHAPE using game theory. Okay, so here if you see this model, certain features you have given to this model like age, sex, BP and BMI you have given, and based on this certain output has been provided. Now in this, what is the implication of this SHAPE? Basically SHAPE is going to provide you the magnitude of impact as well as the direction. So the bar which is shown here, the bar which is shown here, length of the bar, so it shows the magnitude of its impact, and the direction showed the color basically. Okay, the direction basically shows the color. Now how the color changes? So color basically changes based on the associations, whether is it going for positive associations or whether it is going for negative association. Okay, so that SHAPE explanation we will see also at the time of in second video where in second session, where I will explain the working and functionality of this SHAPE along with line. So you see here, there are also certain plots like summary dot plot is there, then bar plot is there, then waterfalls. So these all are generated using this SHAPE libraries. Okay, so force plot is there. So nowadays, we are not going for those kind of plots like where you can import the matplotlib functionality and then you go for directly you can involve certain generated simple kind of plots, right? So we have to switch towards these kind of libraries where the explainability of the model should be governed. So there you can explain the decision plots, like if the model says does such decision, so what is the implication of particular feature in this? Okay, PDP plots, dependence plots, waterfall plots, we have to go. Okay, so there is one more library called Seaborn. From there also you can generate a variety of plots. Okay, but these are the libraries which are specific for these explainable AI applications, right? So then I will cover this line in detail in the next session. So thank you very much for this session. Dr. Ashok. Dr. Ashok, are you there? Ashok ji?
Yes, sir. Very good afternoon. Sorry.
Yeah, good afternoon, sir. So, sir, can we take a break of 15 minutes?
Yes, we have session up to 3 only, sir. So you can take break and let me see if we have any questions.
Okay, we have session up to 3.
Up to 3 only, sir.
Okay, but in the schedule it is mentioned.
Your next maybe tomorrow I will be letting you know, sir. I will let you know.
Okay.
Okay. So
Okay, so I will continue with certain illustrations then.
Fine, sir. Fine.
Okay. Okay, so here if you see in this Lime implementation, is it visible?
Share screen, sir.
Yeah. I hope so. Now, is it visible to all?
Yes,
okay.
Sir.
So here you see that there's a Lime implementation. So in this Lime, what we need to do, first of all, you have to take a general. So I have taken a Boston data set. Okay, so we all are familiar with the data sets where basically we have to take the certain attributes and predict the house prices, right? So certain attributes are there like CRIM. So we have imported our conventional libraries like NumPy, Matplotlib, and Pandas. And then we are going to import the load Boston here by using from the sklearn. And then we are going to import the data, and then the data sets has been described. So right. So here then you see all the data has been listed. Then we are going to, here if you see, all the dataset features has been there. And this dataset you can get from the ML, UCI ML. Then we are going to extract the feature matrix. Okay. And the target variable by doing a train test split method. So we have to import. So I am sure that many of you are aware about this train test split module from the model selection library of sklearn. So then you are going to take the input as well as the output. Now, from this, we are going to extract the features from the data. So what kind of features are there? So that you can easily extract from here by calling this data. And from this data, you are going to split the data into train and test set. So how you're going to perform the train test split? So you have to give the input, output, then train test size and the random states. So once I run this, then you are going to see the train test split data. It has been generated. Okay. Then we are going to create a data frame of the data for this visual check. Now for this data frame generation, okay, you have to define the shape as well as you are going to display the top 5 data of the data set. So only the 5 rows has been there. So which has been generated from the data, which is of size 506 cross 14. Now we have to instantiate the prediction model. Now for this data sets, I am using extra tree regressor as a prediction model. Okay, so we all know extra tree regressor is available in the sklearn ensemble module. Okay, so you have to invoke this module, and from this module you have to call this extra tree regressor. Okay, once you invoke this extra tree regressor, you have to fit the model into the training set. So for fitting purpose, you have to perform this. You have to call this fit function. You have to call this fit function for fitting the prediction. Okay, so by performing the fitting, you have to submit here the training set as well as the of the X of the sample input as well as the output. Then we are going to check the model performance on the test set here. So how you are going to check the model performance? So we all know that the R2 score is there. Okay, so for checking a model performance on the test set, there is a score called R2 score. Through that, you are going to check the performance of the model on a particular test vector, that this model is giving us 91.8% score. Okay, for the test set. Now we have to instantiate this explainer library, that is LIME. Okay, so LIME actually works on the three data set, that is LIME tabular explainer, LIME image explainer, and LIME text explainer. Now, since this data set is of the table size, so I am importing here tabular file. Okay, so once you imported this lime.tabular function, lime.tabular explainer, it is going to take these parameters. What? It is going to take the training set. It is going to take the extracted feature. Now feature we have already extracted from the top. Okay, from there we have taken the features, and then what kind of mode we require. Okay, so the mode we have taken, that is the regression mode, right? And then it is going to explain the entire library, that is by using explain lime. Now what happened in case of this lime tabular explainer, you have to initiate the instance, you have to explain the instance. So for that purpose you have to call this explain instance method. Okay, so what is the utility of the explain instance method? Like, we have to explain the decision. Let's say for my data set I have supplied my 10th test vector. Okay, or I have supplied my 5th test vector. So what logics, what decisions, how the model took decisions behind the prediction for this 5th test vector by displaying the top 5 features. So I only just displaying the top 5 features which is going to be responsible, or which is contributed towards the model prediction. So here I supply this index number, that is I equals to 10, and then these are the numbers which are going to denote the top feature, which is represented by K here. Then how do you call this explain instance method? So for this purpose, you have to call this explain instance method available in the LIME. Then explain instance method basically going to take 3 parameters. So one is the test vector, the ith test vector. Let's say here we are passing the 10th vector. Then prediction function, what kind of prediction we are using. In this case, we are getting regression. Then the top feature which you want to see, how many number of instances we want to see. So that is noted by here K. Okay, and then finally you are going to visualize the explanations by this show in notebook function. So here you see these outputs where you see certain negative associations, and somewhere you are going to see the positive associations. Now you are getting here these 3 results. Okay, that is intercept, prediction, and right. What is the meaning of this right here? Right is going to denote the prediction given by our prediction model. Okay, for the given test set. Now what kind of prediction model we have opted? We have opted extra tree regression in our case. Okay, and what is the meaning of this prediction local? Prediction local is going to denote the value which is output by a linear model. So LIME has already, actually LIME has one surrogate data. Okay, so LIME has taken some surrogate weights. From there you are going to test it on the linear model. But this is what the right which we are performing, that is on the extra tree model, which we have already trained for this input and output function. Then third is intercept. So obviously for a linear model, if I explain the equation W0 plus W1x1 plus W2x2, so this is a linear equation where W0 is nothing but the intercept. So intercept is the constant part of the prediction, which is given by the above linear prediction model. Okay. Now coming to this explanation, we see here these are the colors blue and orange. So blue going to depict the negative association, and positive going to depict the positive association, and orange going to predict the positive associations. Now what kind of prediction here? So here is, you see this 14.81 is the right value which we are getting from this 10.78 to 45.8. Then LS state value we are getting 19.88, this feature value, and actually it has to be greater than 17.02. That's why we are at the higher end. Okay, similarly PT ratio value we are getting 21.0, here we are getting 20.2, which is getting at the higher end. Then higher value of index is there also. Then higher value of, but the RM value if you see, it is 5.88 and it is actually less than the 5.88. So this is here 5.81. So this is the lower value. Lower value of RM indicates less amount of room per dwelling. Okay, so these are the features basically. So, okay, so these features I have explained here already. Okay, what is CRIM? That is per capita crime rate. What is INDUS? It is proportion of non-retail business acres per town. What is NOx? It is nitric oxide concentration. Okay, then average number of rooms. Age is the proportion of owner occupied units. what is this here? Weighted distance to 5 Boston Center. Then red, it is the index of accessibility to radial highways. Tax, full valued property tax rate. PT ratio is people teacher ratio by town. L state is lower status of the population, and B is the 1000, whatever B is the proportion of blacks by town, right? So these are the definitions of the attributes which are available in the data. Now, in this low value of RM, it indicates the less amount of room per dwelling. So through this, we also able to identify this NOx value. Okay, the NOx value, lower value of NOx indicates that low amount of nitrous oxide concentration has been present in the air. Okay, now if you see, if we can change this I value for the test vector, rather than if you want to go for the 47 test vector or 20 test vector by displaying only the top features. So these are the top 5 features you are seeing here. Now going for this feature, once we change this index, okay, automatically the results get changed. Okay, now the correlation has been higher and into the orange side, so which is going to more positive correlations, whereas the negative side, it is lower value because the dis is there only. Okay, so this is there only, which value lies between 3.2 to 5.21. So that is called 4.79. So that is called negative correlation for the data. Okay, so this kind of explainability we have to achieve by using these libraries, okay, or the functions which are designed for the explainability purpose. Okay, similar kind of stuff we will take for other libraries like Lime also there, and LE5 is there also. So I think that time is not enough. So otherwise I can explain the shape also and LE5 also. Okay, so let me show you this LE5 explanation. Okay, so in this LE5 also, similar, I have trained the model, similar kind of same data set I have opted, where I have performed the train split set, everything is same. Okay, we have trained it on the random forest regression, but in the LE5, what important is you have to import this permutation importance. Okay, you have to import this permutation importance module. Now what it perform, it is similar to a feature importance. Okay, so usually feature importance is also known as permutation importance, where you are going to create this permutation importance object, okay, using this model. Okay, which model? LE5 model. So for this purpose, you have to import this LE5. Now directly if you import LE5, it will not work in your system. So first of all, you have to install this LE5. Similarly, you have to install the Lime also. So you just directly write pip install Lime. Okay, so you directly write this pip install Lime and pip install LE5 in the conda prompt. Okay, it will install all the libraries as well as the dependencies which are required in this, and you can go for this permutation importance. So here you see in this permutation importance, it shows the feature. Okay, so among all these available features, this RM has the highest importance compared to all the features. Why? Because its weight is more. Now, before this, in this first row, you see here, every row indicates how much model performance decrease with random shuffling. So in case of LE, what is the logic here? Basically in LE, you have to perform the, you have to take certain sample of some sample data sets. Okay, certain samples you have to take from the data set. Then you train with the another sets. Okay, that is called validation set. Again, you reshuffle the samples, reshuffle them. Then you set another certain samples instance, train the data, get the prediction. Again, you reshuffle. These steps you have to repeat it, okay, multiple times to get the final prediction. Now, these are the numbers. Now, what is the meaning implication of this negative number here? Okay, so this negative implication, this negative permutation, basically, it indicates that predictions are being shuffled on the noisy data. Okay, so these negative results you are seeing here for this ZN and chess feature, so which directly shows that here the predictions are performed on the noisy data rather than the real data. Okay, so that basically affects our results. That's why they are at the bottom. Okay, whereas in case of this highest feature, which is having the positive value, and what is the value which is present after this plus minus, like 0.1291, 0.0249, 0.0065. So this value implies how the performance get varied from reshuffling to next. If you perform one series shuffling, Then if we go for next reshuffling, then next to third reshuffling, so how the performance actually change. So that is basically nothing but the degree of randomness. That is nothing but a degree of randomness across the multiple models, right? And the first number, okay, so this is what the number which is here. And first number actually shows the how much performance decrease with the random shuffling as for the different iterations for different features. So this is the importance of this library. That is what LE5. Okay, so that is all for the session from my side. Okay, thank you.
That was a very detailed and a very lengthy interaction and very lengthy talk by you from 1:30 to 3. This is a very, very long. And in fact, you explained a very innovative and very emerging areas in AI, which is really the need of the hour for the researchers. So let me see on the YouTube live streaming if there is any query I will be sharing with you. Anyhow, we have our head of the department, Dr. Manasji, is here. Manas, sir, please go ahead if you have any queries with you, sir, please.
Yeah, nice lecture by Dr. Aditya.
Thank you, sir. Thank you.
My best wishes. And what I have learned from the entire presentation is basically whatever technique and technology we are using for doing AI are going to be extended to the explainable AI. Right?
Yes, yes.
Is there any new platform or technology being researched these days, like how to implement this?
There are a lot of technologies which are there in the market, like people are going towards IOMT. There is a concept called Internet of Medical Things.
Right.
Okay, which people are exploring a lot nowadays, because due to this COVID pandemic, everybody's want the remote monitoring. I mean, we can monitor our patients from the remote. I mean, we can get the doctor advice. So
Right.
we are going to incorporate such kind of models with the help of AI. Then explainable models are there. Then responsive AI, responsible AI, that is the future.
Right.
Responsible AI means how we can trust our model. What is the fairness in model? What kind of security aspects are available in the model? Accountability. Right. These are the things.
Right. That's all from my side. Okay. Thank you. Thank you very much.
So that's great, sir. That's great. Definitely. But unfortunately, we have some reasons. Otherwise, we would have extended your session to.
Yes, actually, I have prepared 2 sessions.
I understand. I understand this. So most probably the next week we are going to have another refresher course, and where we will be having your experiences which you have. We will be getting time.
Dr. Ashok, let me interrupt. We can invite Dr. Aditya for some other lecture in our specifically for our campus sometimes. Maybe online if pandemic allows, then we go for offline too.
Definitely, sir. Definitely, we will be going for a research symposium.
We will not his hard work to go as waste. So Dr. Aditya will invite you soon in our campus or physically or in online board, right?
Thank you, sir. Thank you. Thank you.
Yeah.
That's great. That's great, sir. That's great, sir. That will be lucky. We will be lucky enough to you in our campus. And unfortunately, because of the COVID, things are really not in a good shape. But otherwise, our head, sir, is always pushing us to go for some offline activities and call some reputed speakers like you. So definitely, sir, we will see you in our campus soon. And once again, on behalf of Department of Computer Science, Badawa Campus, University of Jammu, and Teaching Learning Center of Ramajun College, Delhi University, I thank you. I extend my very, very warm wishes with you for your wonderful talk which you have given here and the time you spared for us. That is really a very nice. And although I do understand that you were there ready for the 2 different 2 sessions you were going to cover, or unfortunately due to some reasons we couldn't get that accommodated. But anyhow, we will keep in touch with you in future, and the experiences which you have in the area of computer science is definitely going to help us a lot. And since the term we told in the end, that Internet of Medical Things, so that is the really need remote. So remote monitoring is going to be in another area, as you already stated in your talk, and as the head sir also said that yes, definitely it's going to be another area. So we will be taking your help, sir, in future as well. Once again, I thank you all for for this kind talk, and we have a very good response to the YouTube live streaming. Everybody is putting a very good remarks there. There is no queries, and thank you, sir. Thank you. We will keep in touch. Thank you.